Imagine this. You're orbiting Earth at over 17,000 miles per hour, in a spacecraft that's more fragile than the room you're sitting in now. You're surrounded by silence so absolute, it makes your heartbeat sound like thunder. Then an alert, not from inside but from Earth. Something's wrong with your return ship, not just a glitch, a failure. The system that keeps your capsule cool during re-entry has sprung a leak. A bad one. The spacecraft meant to bring you home? It's just been ruled too dangerous to use. Now you're stuck in space. And not just for a few days, not even for a few weeks. Try 9 months. That's longer than most people plan to stay in another country, let alone on another planet. This isn't science fiction. This isn't some script from Interstellar or a cleverly written novel. This is real. It happened aboard the International Space Station in 2023, and it tested the limits of space travel, international cooperation, and human resilience like never before. Welcome to Cosmic Whispers, where we don't just tell you what's happening in space and we take you there. Today we're unraveling the astonishing story of 3 astronauts, Sergei Prokopyev, Dmitry Petlin, and Frank Rubio, who were suddenly thrust into one of the most unexpected survival scenarios in modern spaceflight history. But this story isn't just about what went wrong. It's about what humanity can do when everything does go wrong. Because space is not forgiving. It doesn't care about your schedules. It doesn't wait for spare parts. It throws problems at you in the void, and you either solve them or you don't come home. And before we dive into how a critical coolant leak left 3 astronauts orbiting Earth for nearly an entire year, there's one thing you can do to help our mission. Every great journey starts with a few brave explorers. Right now, Cosmic Whispers is just beginning, and your support means everything. If you enjoy unraveling the mysteries of the universe, hit subscribe. It's free, and it helps us grow this community together. So how did it all begin? To understand this story, we have to go back to September 2022. A Russian Soyuz capsule, Soyuz MS-22, lifts off from Baikonur Cosmodrome in Kazakhstan. Now, this launch site isn't just any pad in the desert. It's sacred ground in the world of spaceflight. This is where Yuri Gagarin took off to become the first human in space in 1961. This is where legends are born. Aboard the Soyuz were Russian cosmonauts Sergei Prokopyev and Dmitry Petlin, alongside NASA astronaut Frank Rubio, a former U.S. Army helicopter pilot and physician who once spent his days flying missions in Iraq and El Salvador. This was his first spaceflight. His family watched from Earth. He was expected to be home by spring. The mission was meant to last 6 months, a routine duration for modern expeditions to the ISS. Once they arrived, the crew got to work immediately, conducting microgravity experiments, monitoring how the human body responds to long-term weightlessness, maintaining station systems, and supporting dockings and cargo missions from multiple nations. Then, on the evening of December 14th, while prepping for a scheduled Russian spacewalk, something strange happened. Flight controllers at Roscosmos noticed sensors aboard Soyuz MS-22, detecting a sudden pressure drop in the capsule's external cooling system. That system is designed to keep the internal temperature of the spacecraft stable, something absolutely critical during re-entry, when friction with the atmosphere turns the capsule into a searing metal bullet. Within minutes, external cameras revealed a shimmering cloud of white crystals spewing from the spacecraft, venting into the blackness of space. At first, no one knew exactly what it was. Was it frozen oxygen? Liquid propellant? Could this be a breach in the pressure hull? But it was quickly confirmed: coolant. The external radiator system had suffered a rupture. The cause? Still uncertain, though later investigations pointed to a potential micrometeoroid impact. Tiny, fast-moving pebble of rock or space debris, no bigger than a grain of sand. At orbital speeds, even that can punch a hole in metal like a bullet through paper. With the coolant system offline, the capsule's internal temperature was projected to rise dramatically during re-entry, potentially reaching over 100 degrees Fahrenheit. Electronic components inside could overheat, glitch, or even fail entirely. The capsule would become a metal oven. That alone was dangerous. But consider this: Soyuz is designed as a lifeboat. In the event of any emergency aboard the ISS, from say fire to a depressurization event, it's the escape pod. Now that lifeboat was crippled. Within hours, mission planners at Roscosmos and NASA were faced with a terrifying question. What if we needed to evacuate right now? There were contingency options. The SpaceX Crew Dragon capsule, already docked at the station, could accommodate some extra crew, but not all 3 stranded astronauts. One suggestion included strapping a 4th person into the limited floor space using makeshift restraints, but this was a workaround, not a solution. Ultimately, Roscosmos made a bold decision. Launch another Soyuz MS-23. But launching a replacement spacecraft isn't like calling a tow truck. It takes weeks, sometimes months of planning. Flight dynamics, orbital windows, hardware readiness. Everything has to align, and in this case, that meant launching the new capsule with no one on board. For the first time in Soyuz history, a spacecraft would fly up to the ISS completely uncrewed, not as a delivery vessel, but as a rescue vehicle. As January turned into February, the crew of 3 continued their mission, now fully aware that their return to Earth would be delayed for at least 6 more months. Supplies aboard the ISS were rebalanced, maintenance schedules were adjusted, psychological protocols were reviewed. The crew wasn't just extending their stay, they were entering the unknown. For Frank Rubio, this unexpected twist came with an emotional cost. He had a family waiting at home. His son's high school graduation came and went. Birthdays passed. His mission would go on to last 371 days, breaking the previous record for the longest continuous spaceflight by an American astronaut. But as we'll see in the next section, length is only part of the story. Because space doesn't just test how long you can stay, it tests how well you can adapt. So what was life really like for those 9 extra months in orbit? How did the astronauts cope with confinement, uncertainty, and the weight of isolation? And when the replacement Soyuz finally arrived, what were the risks involved in trusting a new capsule in the same hostile environment? Now that we know, the crisis had occurred and the astronauts were stranded, let's step into their shoes, or in this case their space boots, and try to imagine what it must have been like to float high above Earth with no clear way home for months. At first, the crew handled their situation with remarkable calm. After all, they were trained for this. Astronauts and cosmonauts spend years, sometimes decades, preparing for the unimaginable. They are drilled on everything from microgravity survival to high-stakes troubleshooting. Their lives are meant to be chaotic, filled with complex problems and split-second decisions. But even the best-trained minds in the universe can't predict the emotional toll of a crisis like this. They weren't just floating in space. They were trapped in an isolated tin can, millions of miles away from their loved ones with no clear exit strategy. So, how did they cope? To put it simply, it was a balancing act. On one hand, life aboard the ISS continued much like any other space mission. The astronauts followed their routines, conducting experiments, running maintenance on the station's systems, and monitoring the health of their bodies in microgravity. After all, the ISS is one of the most advanced research facilities ever built. It's a place where scientists study the effects of weightlessness on the human body, test cutting-edge technology, and even produce pharmaceutical drugs that are impossible to create in Earth's gravity. But as each day passed without a clear return date, the weight of their situation grew heavier. One of the first challenges was the sheer mental strain. For months, there were no guarantees. If Soyuz MS-23 had been delayed, if the launch had failed, the crew could have been stuck indefinitely. There's a reason NASA's long-duration flight analogs, studies that simulate what it would be like on Mars or other deep space missions, include so many psychological components. Being in space is like being in a high-stakes, high-risk job, but with no escape. You can't go home at the end of the day, and unlike a regular job, this one literally has no sick days. There's a massive psychological component to long-duration space travel, something NASA has been studying since the 1970s. Isolation, confinement, and the lack of natural environmental cues, like sunlight or fresh air, are huge factors. Even the best of the best can face anxiety, depression, and a feeling of disconnection. Imagine not seeing your family for months, not hearing your loved one's voice, and yet those feelings had to be set aside for the sake of the mission. Frank Rubio, for instance, recorded personal messages to his children. During his days aboard the ISS, he would send video clips to his family, knowing that it might be months before they saw him again. He missed his son's high school graduation, birthdays and family gatherings. Every moment he spent floating there, he was physically absent from his family, even though he was just a video call or message away. That emotional dissonance is something that only a few people on Earth can understand, and it would have added an invisible layer of pressure. But it wasn't just about the emotional toll. The crew still had to perform their duties. Every day, they conducted critical science experiments, all while adjusting to the unique challenges posed by living in microgravity for extended periods. The effects of prolonged weightlessness can cause everything from bone loss to muscle atrophy. So the astronauts had to exercise 2 hours a day using specially designed machines that simulate resistance and help keep their muscles and bones from deteriorating. However, physical activity, while essential, didn't just keep their bodies healthy, it also helped with the mental strain. Exercise in space doesn't just help astronauts stay fit, it helps combat the isolation and sense of helplessness. Every time the astronauts exercised on the station's treadmills or cycling machines, they were doing more than staying in shape. They were maintaining their psychological equilibrium. On the other hand, the challenge was even greater for the station's supplies. The ISS had been designed with a specific mission duration in mind. Crew rotations were scheduled months in advance, and so were food, equipment, and medical supplies. The delay in returning meant that the crew would have to adjust, rationing supplies and relying on additional cargo missions to bring in what they needed. But sending up extra cargo on a timely basis wasn't guaranteed. There were delays. For example, the cargo flights needed to supply them with fresh food and medical supplies had to work around launches, repairs, and the unpredictable nature of space itself. It wasn't just the material resources they had to manage, though. They had to stay healthy, both physically and mentally, without overextending their mental and emotional limits. And while the astronauts worked diligently, their lives became about adjustment. They had to find new routines and comfort in their work, their hobbies, and even their communication with the outside world. They worked out together, studied the stars together, and, when possible, laughed together. They shared jokes over the intercom, played chess, and even celebrated holidays, like New Year's with festive meals. There were moments of normalcy, but only fleeting. Meanwhile, as the months dragged on, engineers at NASA and Roscosmos were working feverishly behind the scenes. Soyuz MS-23's launch was scheduled for February, but it wasn't ready yet. The mission would need to be meticulously tested before it could launch. And each day of delay added more tension. What if it failed? What if there was another issue with the capsule? What if a third emergency occurred that none of them could have predicted? Soyuz MS-23 finally launched on February 24th. But that wasn't the end of the uncertainty. The spacecraft still had to dock with the station. The docking had to be precise. Every millimeter counted. Even a small misalignment could cause a catastrophic collision. Soyuz MS-23's launch was smooth, but the real test lay in reaching the ISS safely. If the docking didn't happen, the crew would remain stranded. And then came the day of arrival, the day when the astronauts were finally going. To be relieved of their months-long wait, Soyuz MS-23 had to dock perfectly. The capsule slowly approached the space station, its engines firing in small bursts, adjusting its trajectory. With each second, the tension in mission control grew. Everything they had worked for, every bit of effort, depended on this one moment, and it worked. Finally, after months of isolation, uncertainty, and human endurance, the crew had a way home. But this wasn't just a victory of logistics, it was a victory of human spirit. The astronauts had survived months of fear, isolation, and uncertainty. But in doing so, they had proven that even in the most terrifying situations, when it seems like there's no way out, hope and ingenuity can carry you farther than you think. So, What does all of this tell us about our future in space? How far are we willing to push the boundaries of exploration, and what happens when even the most well-prepared plans go wrong? Now that we've seen what the astronauts endured in space, it's time to zoom out and look at the bigger picture. The Soyuz coolant leak and the prolonged stay of the crew on the International Space Station is more than just an isolated incident. It's a stark reminder of how fragile human life is when we venture into the vast and unforgiving reaches of space. For decades, space agencies like NASA, Roscosmos, and more recently SpaceX have pushed the boundaries of what we thought was possible in space exploration. But while we've made incredible progress in understanding space, we still face obstacles that threaten even the most carefully laid plans. The risk of human error, technical failure, and unpredictable forces in space is a constant reminder that we're not invincible. This recent Soyuz crisis reveals the true nature of space travel. It's a high-stakes game. What happens when our technology doesn't work as expected? And more importantly, what happens when we send humans into that unknown? Let's take a closer look at the implications of the Soyuz leak, not just for the astronauts involved, but for the future of space exploration. First, there's the issue of reliability in spaceflight technology. The Soyuz spacecraft has been one of the most reliable human-rated spacecraft ever built. For over 50 years, it has been used by the Soviet Union, Russia, and most recently, international astronauts. Its legacy is built on thousands of successful flights. But even the most seasoned spacecraft can suffer from the unexpected. A more micrometeoroid, a grain of sand traveling at speeds of over 35,000 kilometers per hour, was enough to rupture the coolant system. This tiny speck of space debris caused a failure that grounded the capsule, forcing the astronauts to stay in space for months longer than planned. It was a stark reminder of just how much we're at the mercy of forces beyond our control. Every space mission carries risks, but this incident highlighted just how little we know about the true dangers of the space environment. In space, even, the tiniest particles can have catastrophic consequences. A future mission to Mars or even deeper into space will face these risks on a scale we can't yet fully predict. How do we design spacecraft that can handle the dangers of deep space, where debris is more plentiful and the environment is far more hostile? One of the most important lessons from the Soyuz crisis is that resilience is key. We need to build spacecraft that can withstand the unpredictable. This means advanced materials, enhanced shielding, and better systems for detecting and managing damage. The technology that enabled the crew to survive on the ISS during the delay, like the SpaceX Crew Dragon, which is equipped with advanced life support systems, redundancy protocols, and escape capabilities, is a glimpse into the future of space travel. But it's not just about the hardware. Human resilience plays an equally important role in the future of space exploration. When astronauts are stranded in space, it's not just about fixing the spacecraft, it's about the human element. The astronauts' ability to stay calm under pressure, manage stress, and maintain mental clarity in extreme isolation is critical. Space agencies have known this for years, which is why astronaut training is so grueling. Astronauts aren't just scientists and engineers, they're also trained in psychological endurance. The long-duration missions they've been sent on, from the ISS to past experiments like Mars 500, are designed to simulate the mental and emotional stresses of being alone in space for extended periods. During the Soyuz crisis, it wasn't just about surviving in space. It was about holding on to a sense of purpose. The astronauts had to maintain a focus on their mission, the science, the maintenance, the daily routines that would keep them sane. But there were also moments of emotional release. The video messages sent back home, the jokes shared between colleagues, and the small celebrations, like ringing in the new year, helped them stay grounded. This brings us to the broader implications for deep space exploration. If we are to send humans to Mars, it won't be for a few weeks or months. Mars missions will require years of preparation, but also years in space, far from Earth, with no option for immediate evacuation. So, what can we learn from the Soyuz mission? First, we need to acknowledge that even the most advanced technology can't prevent everything from going wrong. Second, we need to prepare not just for the technical side of things, but for the emotional and psychological aspects of being so far from home, cut off from everything familiar. The prolonged stay on the ISS didn't just test the astronauts' technical skills, it tested their spirit. In future missions, we'll need to ensure that astronauts not only have the tools to fix a broken spacecraft, but the mental resources to keep their morale high during extended periods of isolation. NASA and Roscosmos already use advanced psychological techniques to monitor and support their astronauts during missions, but future missions to Mars will push these efforts to new limits. Then, there's the issue of international collaboration. The Soyuz incident, despite its stress and uncertainty, showcased something incredibly powerful: the unyielding strength of international cooperation. Despite the intense pressure and the potential for catastrophic consequences, space agencies from different countries came together to solve the problem. Engineers from NASA, Roscosmos, and SpaceX worked side by side, quickly designing a rescue plan and testing new solutions. This collaboration helped ensure that the astronauts were brought home safely. But in the future, collaboration will take on an even more crucial role. As humanity extends its reach beyond Earth, the cost of space exploration will only grow. A Mars mission will require an incredible amount of resources that no one country can bear alone. For future missions to succeed, countries will need to work together in ways they never have before. A Mars mission will be a test not just of our technology, but of our diplomacy, of our ability to set aside differences and work for a common goal. If we can't pull that off, the dream of sending humans to Mars might remain just that, a dream. And there's one more crucial lesson from this incident: we need to develop new propulsion and return technologies. While the Soyuz spacecraft is a proven vehicle for getting astronauts to and from low Earth orbit, it's not designed for deep space exploration. For missions beyond the Moon, we need advanced propulsion systems that can get us to Mars faster and more efficiently. We need to ensure that these spacecraft are more reliable, capable of withstanding the dangers of deep space. And we need to have multiple contingency plans in place, because, as the Soyuz crisis proved, even the best-laid plans can fall apart. What if the astronauts on the ISS hadn't been able to wait for the Soyuz MS-23? What if their spacecraft had been beyond repair? What would have happened to them? These are the kinds of questions that future missions will need to answer, and soon. As we continue to explore space, the stakes will only get higher. The Soyuz crisis of 2023 was a wake-up call, a reminder that even in the age of advanced technology, human space exploration is a perilous endeavor. But it's also a reminder of just how far we've come and just how much further we have yet to go. The question is, are we ready? Are we ready to take that next giant leap, not just to the Moon but to Mars and beyond? As we wrap up this incredible journey, it's clear that space exploration is far from straightforward. The ordeal of the astronauts, stranded aboard the International Space Station for nearly 9 months, wasn't just a logistical nightmare. It was a testament to the power of human perseverance, cooperation, and innovation. But beyond the immediate survival and triumph of that mission, the question remains: what comes next for humanity in space? The Soyuz crisis highlights a fundamental truth that we often overlook. Space is a dangerous, unforgiving place, and as we venture farther into the cosmos, the danger will only grow. If we look at the long-term goals of space exploration, missions to the Moon, Mars, and beyond, the challenges become more complex and more perilous. We can't just rely on the same systems that brought us to low Earth orbit for decades. We need to rethink how we approach space travel. Let's think about it. Mars. The red planet is the next giant leap for humanity. It's our best shot at establishing a permanent human presence beyond Earth. But it's also an incredibly difficult challenge. A Mars mission will take years, not months. And during that time, astronauts will face isolation, resource scarcity, and perhaps most daunting of all, the psychological strain of being so far from home. Mars is an average of 225 million kilometers away, over 6 months in transit. Even with the most advanced technology, there's no quick way back if something goes wrong. The astronauts' lives will depend on their ability to survive in an environment where every decision matters. A Mars mission will also require entirely new technologies. One of the major hurdles will be life support systems. The ISS is an impressive example of how far we've come in space sustainability. On the station, astronauts recycle air and water and grow their own food in small greenhouses. But on Mars, everything will need to be scaled up. The atmosphere on Mars is primarily carbon dioxide, with almost no oxygen to breathe, so we'll need to develop self-sustaining habitats that can extract oxygen from the Martian environment. We'll need advanced water recycling systems and food production methods capable of growing crops in Martian soil or hydroponic systems. And that's just to survive. For astronauts to thrive, they'll need more than just basic sustenance. They'll need a sense of connection to Earth, a sense of community, and the ability to manage the immense psychological pressure of being so isolated. But technology is advancing at an incredible rate. SpaceX's Starship, for example, is being designed specifically for deep space travel, with the ambition to transport humans to Mars and beyond. Unlike the Soyuz or even the SpaceX Crew Dragon, Starship will be capable of carrying large crews and significant cargo, making long-term missions far more feasible. Starship is designed to carry astronauts on missions that could last several months or years, with the spacecraft being reusable, potentially reducing the cost of such missions. But Starship isn't just about getting us to Mars, it's about enabling the future of human settlement on other planets. If we want to live on Mars, we need to build a sustainable colony. This means everything from generating energy on Mars, likely through solar or nuclear power, to building habitats that can withstand the planet's extreme conditions. This is why NASA is already testing regenerative life support systems that can recycle air, water, and waste, providing everything astronauts need to survive. They're even studying how to use Martian resources, such as extracting water from the ice beneath the surface or using the soil to create building materials for habitats. All of this is essential to making sure that a Mars colony can not only survive but flourish. But we can't stop there. Mars is just the beginning. Beyond Mars, the next frontier is the outer planets, Jupiter, Saturn, Uranus, Neptune, and their moons, which might hold the key to discovering life beyond Earth. For example, Jupiter's moon Europa is considered one of the top candidates for finding extraterrestrial life. Beneath its icy surface, there's an ocean of liquid water. And where there's water, there's the potential for life. But missions to these distant worlds will push human technology and endurance to new extremes. If humanity is going to explore the outer reaches of the solar system, we'll need to develop new propulsion methods. Current propulsion technology, such as chemical rockets, won't be enough to take us to the outer planets. Nuclear thermal propulsion or even ion drives could allow us to travel faster, reducing travel times and making deep space missions more viable. These technologies are still in the early stages, but they hold the promise of turning what were once science fiction ideas into reality. And then there's the ultimate goal of space exploration, interstellar travel. The idea of traveling to other stars, perhaps to exoplanets in the habitable zone, has captured our imagination for generations. But, realistically, this is still a long way off. The closest star system, Alpha Centauri, is over 4 light-years away. That's more than 40 trillion kilometers. Even with current technology, it would take tens of thousands of years to get there. But scientists are already beginning to think about ways we might eventually reach other stars through advanced concepts like breakthrough propulsion methods, or even harnessing the power of light sails to accelerate spacecraft to relativistic speeds. But in order to get there, we'll need to ask some tough questions. Can humans survive the journey to another star? Can we protect ourselves from radiation, from the vacuum of space, from the mental strain of living in a spacecraft for decades? We'll need breakthroughs in medicine, space habitat design, and long-term resource management before we can even begin to think about interstellar travel. As we look to the future of space exploration, one thing becomes abundantly clear. Humanity's future lies beyond Earth. The Soyuz incident taught us just how fragile our place in space is, but it also showed us how far we've come. It proved that we have the ingenuity, the determination, and the spirit to survive in the harshest environments, even when the odds are stacked against us. So what's next? It's a journey that will take us further than we ever thought possible, a journey into the stars. And while there will be setbacks, obstacles, and challenges, one thing is certain: we are destined to explore, to push the limits of human potential, and to look beyond the confines of our home planet. The Soyuz crisis of 2023 was a testament to the human spirit, a reminder that space isn't just about technology, it's about people. And as we venture into the future of space exploration, we must keep in mind that each new challenge we face will only bring us closer to the stars. What do you think? Are we ready to take the next step into the vast unknown? And what do you think the future holds for humanity beyond Earth? Let's discuss this fascinating journey together in the comments below. If you enjoyed this deep dive into space exploration, like this video, share it with your fellow cosmic explorers, and let us know your thoughts. What's the next great challenge we should tackle? Or do you think we've got what it takes to make the leap to Mars? The universe is full of mysteries, and we're just getting started. Thank you for joining us on this adventure, and as always, keep looking up because the cosmos has so much more to offer.